Okay, good morning, everybody. Thank you for bearing with us for a couple of minutes there while we worked out a technical difficulty. My name is Mitchell Page. I'm the Instrumentation and Control Valve Product Manager for Gerrie Electric, and today we're going to go through some of the products and services for the heavy industries from Samson. We're very excited to have them on board as a partner, but before we go into a little more detail and I let Chris drive, I'm going to take just 2 or 3 minutes and provide a little bit of context of how we got here and where we're going. It should hopefully give you some idea as to what value this will bring to you as one of our Gerrie customers. Before that, though, I'd just like to let you know there is a few things to Microsoft Teams you might not be aware of. One of the features is if you would like to submit a question in the Q&A, you can do so anonymously. Should you not want to have personal or company details sent out, you can do so anonymously and we will get them privately. From there, if you would like them to be responded to in private without being published to the group, we can respond to them privately. If Chris is talking, I can interrupt him. I always like a good opportunity to interrupt Chris, so we can either respond to it privately or we can publish it out to the group. And then finally, a recording will be available afterwards, and we can send that out if you'd like to hear any of the information again or see it again. So before I hand it over to Chris, I'm just going to quickly give you an idea of why we formed this partnership with Samson and where we're going as a company. So a number of years ago, Gerrie Electric formed the Geary process group. And the reason I've got the Rockwell Automation symbol there is it was really focused around supporting the Rockwell Automation distributed control system, Plant PAX, as well as providing some setup services and staging services to complement those of an integrator or an OEM. We also have network design services, thin client deployment, and really have tailored our offering to be focused on the needs of the process industry, hence the name, the Geary Process Group. From there, we partnered with Anderson Hauser, who is a strategic partner of Rockwell, a number of years ago. And what this allowed us to do was provide not just the control aspect of a process distributed control solution, but it also now we can provide the measurement aspect as well. So if you think about a typical control loop, now we can kind of support even more of what will go into a typical control loop, not just on the product side, of course, and the design side, but on the service side as well, being an authorized service provider for Anderson Hauser. Being an authorized service provider means we can provide the same level of service as their own technicians would from the factory. But even with these two leading manufacturers, it really didn't become a true end-to-end solution until we partnered with Samson. So we partnered with Samson, really it became official January of last year. And our partnership with Samson allowed us to really provide sort of that end-to-end solution. If we're talking about what would be required in the process industry, a lot of the loop will revolve around a control strategy, an instrument for feedback, and a valve in almost all cases. So we're excited to be able to support their line of products and to be working with them. It allows us to be in a unique position in the process industry to kind of do the whole thing end to end and not just focus on one area. And we're very excited to be able to partner with these leading manufacturers who work together closely on a global and North American scale. So I'm going to pass it over to Chris, who will introduce himself and introduce a little more of the products and services that are available, that are supported by Gerrie Electric to enable our process customers to have access to this kind of end-to-end solution. Chris, I'm going to stop sharing my screen. You can share yours, and then you can take it away.
Thanks, Mitch. Can everybody see my screen?
Yeah, it should be. I can see it. They're muted, Chris. So,
okay,
but
that's fine.
They can see it. Yep.
Okay. So thank you for that, Mitch. Yeah, my name is Chris Cousineau. I've been with Samson a little bit more than a year now. I'm the Ontario Regional Sales Manager. But prior to that, I've had a lot of experience. I was an instrumentation product manager for a few years with Anderson Hauser, actually. Excuse me. So I have a lot of experience in different types of industries. I'm an instrumentation technologist. So if there's any questions that come up from a process side or just even how the valve fits into things in general, please feel free to let me know. I'm going to go through a brief introduction on who the company is, talk about some of the different types of valves, where we would use them. As Mitch indicated, if there's any questions, please send them to him, and he's quite adept at interrupting me, so I'm sure he'd be happy to do so again. So Samson is I always ask people, have you heard of Samson? And a lot of people say, yeah, I've heard of Samson, but I don't think people realize how long Samson's been around. Samson was founded in 1907 by Herman Sandbos, who was actually a carpenter. He's the gentleman in the bottom right-hand corner of your screen. And the first patent he came up with was a Bellows operated regulator. The company then moved to Frankfurt in 1916, and actually if you look at this picture on the left-hand bottom side of the screen, that building is still there today in Frankfurt. It actually survived both of the wars, and if you ever do get a chance to go to Frankfurt and see our campus, which is huge, please do. You will see this building, and please ask for a tour and see some of the great manufacturing things that we have to offer. Understanding that we need to be able to service different regions, we opened a North American office in 1983 in Toronto, actually in Markham, Ontario, and that's the same office we're in today. So from a Canadian or even North American perspective, we've been around since 1983 in Canada. From a production standpoint, again, being able to take care of the North American market, we realized that we need more ANSI flanges, for example, than DIN flanges. We need more CSA products than European approvals. So as such, they opened up a production facility in Baytown, Texas in 1992. So a lot of the products that we bring into Canada right now come from either Germany or from the US, from Baytown, Texas. To date, we are the third largest global control valve manufacturer worldwide. So we're an independently owned company, and again, we're a worldwide company. I always like to mention this for a few reasons. One thing is that we're not a new company. As I said, we've been around for over 100 years now. We're very stable, even the current marketplace economic situation that we're in, we're still a very stable company. But what's also important is that if you have equipment that you as a customer or your customer's manufacturing that's going into another country, we have Samson subsidiary offices around the world, in China, Russia, Europe, India, Africa, Australia. So the reason why I mention this is we see it all the time. Equipment comes over here and we're able to service it. It comes in from Europe or China, and we're able to service it for our customers, and vice versa. We had a situation last year where a customer had built a product on a skid here, sent it off to Romania. They had an issue with it, and we were able to contact that subsidiary office in Romania, have them send a technician to take care of the valve. We started in Europe, obviously, and as such, some of our core competencies and strengths were revolved around that market. So chemical, petrochemical, oil and gas, refinery, industrial gases, these are things that we've been doing for many, many years. So if you think of liquid natural gas, for example, and the industrial gases and cryogenics, that's something we have valves that are very specific that work on. Pharmaceutical, biotechnology, food and beverage is also a market that we have a lot of experience in. Power generation, pulp and paper, mining metals, water, wastewater, iron, steel. So pretty much every one of the industries that we service here in Canada, Samson has either expertise here in Canada or globally in these different industries. So just to give a brief product overview, this is some of the points that I'm going to touch on as we go through this. Self-operated regulators, linear control valves, why are we still using them? Quarter turn control valves, what are the applications for them, the differences between them and linear? isolation valves, linear and quarter turn actuators, and finally positioners and accessories. So a self-operated regulator. In essence, a self-operated regulator is just that. It's what we like to say, it's a set it and a forget it. It's a mechanical device. You don't require any external 4 to 20 signal or any air operation or anything like that. It basically uses the line pressure or temperature and then mechanically regulates to where you need to be. So some applications where you would see this is where a customer has something in a remote location where they don't want to touch it, or the pressure or line temperature or line pressure just needs to be kept at a constant. So those are examples where you would use this. In 2020, as Mitchell mentioned earlier, we talk about what Anderson, Hauser, and Rockwell has to offer. We're really talking about digital and control. So from a control valve perspective, we see a lot more control now than we ever have. People want 4 to 20. People want to be able to make the valves open and close and not just leave them. But surprisingly, there's still a fair amount of applications where self-operated regulators are required. So I'm just going to touch on these briefly. The two that are probably the most common are the pressure regulators. And in essence, what you have is a pressure port on the upstream or downstream of the valve body. And depending on what fluctuation that has, whether it increases or decreases, it then comes into, if you notice here, I hope this works. You notice here, that's your diaphragm. It's fed into the diaphragm and then makes an adjustment based on how much pressure is needed to either open or close the valve. That's how the regulator works, whether it's the pressure or temperature styles. We can go up to 4-inch, we can go higher for specialty applications. ANSI 150 to 300, different body materials available, different diaphragm materials are available also for different pressures, for example, or sometimes higher vibrations. And you can have a set point up to 400 PSIG. One thing to note is that the valve body here and also on the temperature regulators are the same valve bodies that we use in our globe valves. And the reason for that, it just means it's very modular. There's nothing overly special if you need to maintain it. It's a lot of the parts that we use on the globe valves already. The temperature regulator, very much the same as the pressure. The difference is now we have a thermometer or some type of thermostat, where basically as the temperature increases, there's a thermal oil that expands, not unlike a thermometer we're used to, and then we see this, it would either move the plug up or down. So we have different variations depending on what the application calls for. We can go up to 10-inch, 150, 300 pound. Again, we can go into specialty materials if need be. Set point range from -10 to 250 degrees C. We can go higher depending on specialty applications. If I draw your attention to this little picture in the bottom right-hand corner, this is one where we're actually taking the inlet, in this case AB, and then we're, a certain amount is going through A and a certain amount is going through B. So whether we're doing a cooling application or a heating application, this could be something that's controlled with that regulator. I'm going to talk about linear control valves now. I'm going to go through a fair amount of this. Linear control valves are globe control valves are actually very versatile. One of the reasons why they're still so widely used today is because you can use them on different applications. Liquid, gases, combination of that, for example, cryogenics, as I mentioned earlier, steam is something that we use on this. But the other main thing is that it gives you really good controllability. Okay, so when we compare it to different types of valves, yes, they can do control, but globe control valve still gives you a very, very tight controllability. It's not a direct correlation, but if you wanted to equate it to something, equate it to accuracy, in quotations, the most accurate control you're going to get is out of a globe control valve. So you can see here, just very quickly going from left to right, we have different valves for different applications: low flow, hygienic, steam, high pressure, cryogenic, and then some specialty ones along the bottom, which I will touch base on as I go forward. So I'm briefly going to talk about some of the globe control valves we have that are most common for us. We have what's called our 3241 globe valve. And that's really the most standard that we have. And what I mean, it's the most common. We use it for steam, again, water, cryogenic applications. We can go from a 1/2 inch to 12 inch, 125 ANSI class to 300. Very modular design, which I'll touch base with in a moment. When we look at higher pressures and higher temperatures, we go to what's called our 250 series. And if you look at this picture right here, I hope you can all see my pointer. You can see it's basically the same design, but just the valve body is a little beefier. So it can take higher pressures, for example, higher temperatures. The diaphragm or diaphragm in the actuator is a little further away from the body here. And that's probably for a temperature rating. You want to get a higher temperature, so you move it further away from the process. There are some specialty applications where you need to use a caged retain seat. We typically don't use a cage retain seat. We just use a seat guided. And in essence, what that means is, and I'll show the seat and plug in a minute, but it's basically the plug comes directly top to bottom into the seat, and it's guided into the seat. The cage retain means there's a cage in there as well, but what that does, cage retain is actually great for higher vibration types of applications. Okay. Most of the valves that you're going to see from a globe standpoint will be a straight through. You come in on the what we call the A side, you go out on the B side. There are applications where you want to put an angle style valve. Usually if for severe applications, potentially if you have flashing or cavitation, which I will touch base on, or if you just have a piping configuration, if it's an elbow in the corner and you have room to put the valve, that might be a reason to do that. And also we have what's called a three-way style. And the three-way style is for mixing or diverting. The best way to explain it is, again, if you're looking at the left-hand side here and you're coming into the valve, do I want to go divert to the bottom, divert to the right, or do I want to take what's coming in and mix it from the bottom and out? So depending on your application, that's where you would use the three-way valve. All right. One of the things that Samson prides itself on, and one of the main things of our design is we try and be modular, but okay, and I'll show the modularity, and I'm going to talk about reduced maintenance, but I think the key word to take away here is reduced. We try and reduce the size of the valve, we try and reduce the maintenance, we try and reduce the amount of pieces, because in essence what we're doing is we're reducing the amount of times that a customer or technician has to go and actually spend time on the valve. A valve is a mechanical device. It's going to wear. It's like our cars. They all need maintenance. What we at Samson have tried to do, and very successfully I think done, is with our modular design, we're able to reduce the amount of times or reduce the time that the valve is out of the production line. Okay, so I'm going to touch base on some of those points specifically. So this is how a valve is basically built. So you have this bottom part's called the valve body. And then if you can see this little bluish portion there, that is what's called your seat. And that actually threads into the valve body. This yellow piece is what's called your plug. All right. And this is, in essence, that's what a Samson globe valve body setup is. Very simple, nothing more than that. Next, you have what's called the bonnet. And the purpose of the bonnet is to connect the valve body and the plug to the actuator, which is coming in a moment, which is right here, okay? This is a very simple setup of a valve, but in essence, that's all you would need. Valve body, plug, seat, and some type of actuator. And the purpose of the actuator is to move the plug up and down in the seat, depending on the flow rate and control that you need. So here's another situation. You see the same thing, but yourself or the customer has come back and said, well, I actually want a positioner on there. The beauty of our design is, as you can see here, nothing has changed. The bonnet's the same, the valve body is down the plug. But now we've just changed the actuator design. And by just putting on a different type actuator, we now have a positioner that's mounted on there as well. Okay, but nothing else below that positioner has changed. Same thing here. I'll just comment that all we've done is added a gauge block on the positioner, but everything else is the same. So you can see up to this point, everything's the same, but you know, hey, Chris, I bought this valve and I need a manual override on the valve. So all we have to do is, oh, pardon me, is add that to the top. So again, nothing of this below here is changed from there to there. So you can imagine from stocking pieces, you can imagine from designs of other valves, if these changes need to be made, they may need to be sent back to the factory. They might be sent back to the manufacturer. It may have to sit in the shop until pieces come in. You can see ours is very simple to work on. And then lastly, in this case, we're going to add a bellows, which I'll talk about in a minute or two. But the valve body, the plug seat, the bonnet, the positioner's changed a little again. We've just added some accessories, but it's the same positioner and it's the same actuator at the top. So think of it from a spare parts concept. Think of it from everything that you would need to maintain or work on this valve. You don't have to replace the entire valve. You can just replace the pieces that you need. And again, I use the word reduce. We pride ourselves on reducing the amount of pieces that are needed to work on the valve and to get the valve operational and back in service. So just quickly now, if we look at the valve bodies going from left to right, you can see that we're changing the plugs and the seats and the valve bodies, but that nothing else above those has changed. So again, the same point that I mentioned before. So this gives you a better idea from a spare parts side of things, is that how we work our modularity and our reduced maintenance in. So you notice here a seat, for example, from a 1/2 inch to a 1 inch, well, it's the same size seat. So if you have a 1/2 inch valve in stock, or a 1/2 inch valve kit that you have in stock, and you need to make adjustments on a 1 inch, it's very likely you can use the same seat. 1.25 to 2 inch, you see the same thing, 2.5 to 3, and so forth. Plug assemblies are even better. As long as the plug has is able to handle and can work with the same CV. Now I'll stop for a moment because I'm going to use the term CV a lot. CV in essence is the ability to put flow through the valve body. It's a calculation, it's a coefficient, it's a little specific. The number itself isn't as important as understanding the magnitude of the number. So small CV means a small amount of capacity that can go through the valve body. A larger CV number or a larger number means there's more flow capacity that can go through that. And that would be for the same valve size, for example. So getting back to the slide, if you see that the plug for a 1/2 inch can be the same plug as a 2 inch, as long as the CV value works for your application, there's a good chance you can take that out of your stores and use it in that application. So now you don't have to worry about extra parts again. The packing, even better, the packing goes from a 1/2 inch up to a 3 inch. We use the same packing. And there's no stipulations on the valve size for packing up to 3 inch. Okay. So again, being able to be very modular, reduce the amount of parts that are required, reduce the amount of times that you actually have to touch the valve. Here's a CV table, and the reason why I bring this up is to do nothing more than just reinforce the point I made a moment ago about the plugs. So let's take a look at a 1 inch on this bottom. And again, the value, the numerical value isn't as important as understanding that at a 1 inch valve, if I have a 1 inch valve that's running at a CV of, we're going to say 0.5. All right. And now I have a situation where I have a 2 inch valve and I want to use the same plug that I have, but I'm actually running at a higher CV rating. Well, okay, well, what CV rating are you working at? Well, we're actually working at a CV rating of 2. Well, if you follow that from 0.5 to 2, you see that, yeah, we can use the same plug. The same plug that was used on the 1 inch can now be used on the 2 inch. So again, you don't have to contact our good friends at Geary. You don't have to contact your stores and try and get more parts. You can use the existing parts you have in stores. I mentioned this already, so I'm not going to go through it too much in depth, except to show this is the modularity. This is the how simple it is to build one of these. Mitchell and I have both been tasked to build these on occasion during our training. But you can notice here in the valve body, you have a valve body, you have a seat, and you have a plug. If you were to ask us for a replacement seat and plug kit, all you would need would be the seat, the plug, and there's one O-ring that goes between the bonnet and the valve body. But that's it. So you have 3 pieces, nothing else. A lot of other designs, I mentioned cage retain earlier, for example. A lot of other designs have multiple parts. They can have up to 14 or 15 parts in that spare parts kit. So obviously trying to maintain this assembly is a lot easier, a lot simpler, a lot faster. A couple other advantages we have, I mentioned the packing. The purpose of the packing, I'll just go back one. The purpose of the packing is right here, if everybody can see the pointer. I'm on the left-hand picture. If everybody can see that. Purpose of the packing is to isolate the process from the environment. So you can see here that as this plug goes up and down, there's a potential for process to get in here and come out the top, come out this portion of the bonnet, which obviously, depending on what that is, you don't want it. You don't want your valve leaking, but you also don't want that getting into the environment, depending on what it is. This packing is a wear point. There's a plug here that's going up and down and up and down, and eventually it's going to wear, and it doesn't matter whose design or who the manufacturer is, everyone's packing will need to be replaced at some point. What we've done with our packing is we have what's called a self-retained design. Traditionally, what happens is a packing gets put in, and it's usually graphite or PTFE or some type of carbon fiber, and it's packed down, hence the word packing, with a nut. That's this blue portion up here, and it's tightened down. Over time, the packing is going to start to wear. As the packing wears, you have to tighten down the nut some more to compress it, to get more compression, and pack it down until you get to a point where you can no longer pack it down, at which point the packing needs to be replaced. Okay. What we've done is twofold. One is we've come up with this, I like to call it these V shapes or V ring, and basically that acts as kind of its own compression. Okay, you can imagine if you have a bunch of pie plates, how they all come together. So it's a much tighter fit, much tighter compression. The other thing it does, or the other thing that we've done, is we've actually put a spring in here. So it's spring loaded, which means once you tighten down this nut, you don't have to go back and adjust it. That's a real big advantage to this. Again, low maintenance, reducing the amount of times we have to touch the valve. So once this is tightened, you don't have to go and change it. Should you see any type of leak come out of there, it means that the packing is completely gone and you do need to replace it. Our packing also has what's called a B1 classification. That's an emissions rating. So it's less than 100 ppm emissions as standard. So we have a low emissions packing as a standard out of the box offering with no extra charge. Some of the advantages to the seat assembly is that we have less friction. We're not sealing against the threads. We're actually sealing against the body itself. There's no shims and so forth. So it gives us a nice clean seal against the valve, the plug to the seat, sorry. So I just mentioned a moment ago, we have emissions, and these emissions, or the packing is set up to give you 100 parts per million emissions protection. Should you require higher protection than that, we actually have this metal Bellows seals, which I talked about earlier. Again, keeping with our modularity, if you look at the picture here on the left, or center, if you will, you can see it basically fits just between the valve body and the bonnet. And literally the plug has an NPT connection that screws into this chamber that connects back to the stem that goes through to the rest. What this does is it gives you 100% complete mechanical seal, because picture here, you see the yellow, that's actually your process. And your process is completely contained in this area. Should there be any type of leakage, it goes into this green area, and you can see there we have a test connection for a pressure alarm or a pressure gauge, pressure transmitter, something that says, hey, I'm now getting a pressure rating here, or pressure reading. That's usually an indication that the bellows has failed or might have a slight leak to it. So you have this as one level of protection. You have the pressure switch as another level of protection. And then, of course, your packing is right here at the top. So you still have that third level of protection. So if you're worried about emissions, if you're worried about anything getting out into the process or your process getting out into the environment, a metal bellow seals is an excellent way to go. And again, it's very simple to install. It's very modular. I mentioned we want to reduce. One of the things we do is our footprint. We have a very compact design. This is just an example of that design. We took 3 manufacturers, us being one of them, and did a comparison of a 2-inch globe valve with an ANSI 300 flange raised face at an A216 WCC carbon steel body. You can see this one here to the far left, the larger one. It runs about 140 pounds. So you can imagine at 140 pounds, you need multiple people to carry it. You might even need a crane or something like that just to get this installed. 140 pounds, you might even need pipe supports. If you go to the far right now, this manufacturer is 95 pounds. So a little bit less than the other one, but still 95 pounds, it could be a situation where you still need multiple people to carry it and lift it, potentially pipe supports depending. So our valve in the equivalent specifications that we have there is only 50 pounds. And that's one thing we do. We try and reduce the size and make sure that we keep things as compact as possible without giving up any of the performance or the accuracy. One of the ways we can do this, and I'm just going to jump back for a second. If you notice this design here of the very, very large one to the far left, the reason why it's so high is it has one very large spring here that works on the actuator. This design as well has a very large spring. When you look at our design, what we have in our actuator is actually multiple springs. We can start with as low as 3 and go up with as high as 18. And how we do this is, if you're familiar with the Russian doll, where there's a spring inside, or a doll inside a doll, and it just gets larger and larger, we have the same thing. So we can put different springs inside of springs, up to 18 springs inside one actuator. So this allows us to keep things in a more compact, because if you needed to increase your size or change your range, you don't have to change one spring and hence change the size of the actuator necessarily. It might just be as simple as adding more springs, which is very simple to do. It also allows us for less hysteresis. And what I mean by that, if we're familiar with the best way to describe hysteresis is from the time a signal comes in to a pressure signal or digital signal comes into the valve, how long does it take to actually react to start moving before it gets to set point? On one large spring, you can imagine that it takes a little bit longer because you have to overcome those forces on that spring. With multiple smaller springs, it actually reacts much quicker. So that's one of the nice advantages. The other thing is with multiple springs, you actually get a longer life out of the diaphragm. And the reason for that is you're not putting pressure on one point. You're doing pressure. You're doing pressure all the way around the diaphragm itself. And you're distributing it evenly. The other nice thing is that we have what's called a rolling diaphragm. So if you can picture a straight piece of paper as your diaphragm, as you apply pressure on that, on the ends it's going to bend, right? And if so, as such, those will be your wear points. By making it a rolling diaphragm, and I apologize, I'm sure it's hard to see here. I'm sure it's hard to see here. But basically that rolling diaphragm means that there's a lot less stress put on those two connections on the side. So again, we're getting a lot longer life out of our assembly. Just real quick, the other two things to mention is this one here with, you see the orange, that's set up in what we call our fail close. And for us in the electrical field, if you're familiar with normally open and normally close on a switch, a valve is no different. You have a fail close or a normally close, or a fail open, a normally open. The beauty of our design is that, again, we're trying to reduce the amount of times that anything needs to be done to it. If something does need to be done to the valve, it's very simple to do. So what we've done is made it very simple so that in a fail close position, air gets introduced to the bottom here, applies pressure, and then the stem moves up. Pardon me, the stem moves up. Should you decide that, hey, I needed to switch that to fail open, you actually don't need any other external tools, any other parts. You can literally flip. There's the diaphragm here in a plate. You can flip the springs. The only difference is you can see how the air would be piped in to the body here. In this case, you have to pipe in the air to the top. Okay, so usually a piece of tubing would take care of that. But that's all that's required. And we'd be happy to show you how to do it, or we actually have YouTube videos that show you how to do it as well. So far, I've talked about electric actuators. I'm just going to touch on pneumatic actuators really, or excuse me, we talked about pneumatic. I'm going to talk about electric real quick. So there are instances where people would require an electric actuator. And for those of us that have some of the instrumentation or electrical background, electric actuator is basically a motor with gears that takes different voltages, 24 volt, 110, 220, and so forth. We have two different types, one that can thrust up to 2.5 kilonewtons and one that can thrust up to 7.3 kilonewtons. The difference from the one to the other is the top one, the 3374, is strictly electric. The bottom one is electric pneumatic, because when you get to a certain point, you can imagine on much larger valves, the size of the motor you would need, the electric motor you would need to get the thrust needed to actuate and get the travel of the plug into the seat. So instead of just making a very large electric motor, what we've done is we've taken an electric motor with a hydraulic piston inside. So you get to a certain point, like a hybrid car, where you just flip from one to the other. It's the same thing with the electric hydraulic actuator. You get to a certain point where you have to get into the piston, which gives you that extra thrust to get up to the 7.3. So far, we've talked about nothing but great situations. You know, there's a non-critical flow. Quickly, I want to talk about cavitation and flashing. Cavitation and flashing are the two biggest enemies of any type of valve. Cavitation is basically the process media is trying to change state. It's not completely there yet, but it's trying to change state. So if you think of water trying to go to a gas, what happens is it starts forming bubbles. As it comes through the valve, you get to, if you see here, this graph with all the P's, that's representing pressure. And what happens is when you come into the valve, there's a pressure drop. And in that pressure drop, the pressure can go below the vapor pressure. This is why it starts changing state. As you come out of the valve body, you actually recover that pressure. So cavitation is, you haven't quite changed state yet, but as you start to get into that recovery, those little bubbles start imploding and they cause damage to the valve. Flashing is you've gone all the way. You've gone from a liquid to a gas. So in this case, you have bigger issues to contend with as well, because you started with a liquid, you now have a gas, right? Which can still cause issues on the throttling. It creates additional noise and can cause damage to the valves. Most times we're able to size this and say, hey, Mr. Customer, if you use a 2-inch valve, you'll have no problems with cavitation or flashing. However, there are many instances where a customer says, that's great, but I only have a 2-inch line and I'm not changing my line size, and this is my flow condition. So how do I deal with that? Well, how you deal with that is you actually use different plug and seat assemblies to reduce the velocity of the flow coming in. And as doing so, you're manipulating the pressure drop across. The pressure drop that happens in here, okay? So to give you an example, this is a perfect example off to the right here. You can see that the velocity or the flow is going to come in through the bottom, and the velocity is going to be reduced because it starts going through all these chambers. And then even when the velocity hits the bottom of this parabolic plug, the pressure or differential pressure that's created is actually manipulated better. Okay, so it's a lot less gradual. So this is how or it's a lot more gradual, I should say, and that's how we're able to get away from cavitation and flashing. This depicts it even a little bit better, because here we have an AC3, which has 3 pressure reduction stages, and here we have an AC5. So again, all we're doing is reducing the velocity and manipulating the pressure so that the inlet to the outlet, we don't get flashing or cavitation. The ones I showed previously for liquid, these would be the ones we would use for gas. And again, I'm not going to go into too much detail. You can see that they do the same thing. If the flow comes in here, you reduce the velocity, and as such, you're reducing the impact of noise, cavitation, and any type of flashing that happens. Here's another example of one. We're just manipulating it on the downstream instead of right in the valve body or the upstream. I mentioned earlier that we can do specialty gases. So for air separation, liquid natural gas, this is how it's done, which is basically, if any of you are familiar, most natural gas a lot of cryogenic applications are in what's called a cold box. And as such, the valve is submerged into that, and this whole area is completely iced up. So should the valve need to be worked on, you're not in a position where you can go in and work on the valve. So our design allows you to basically take out the plug and seat assembly without having to get all the way into the bottom of the valve body. This is another specialty type of glow valve we have. I'm not going to spend a lot of time on it, but if anyone has any questions on this, please feel free to reach out to Mitch or myself. This is basically a de-superheater valve. And what it does is it takes superheated steam, injects water into it, which brings it down, not quite the saturated steam, but starts cooling it to a de-superheated steam that can then be used in the process. Large industrial facilities is where you'll see this. Large steel mills, for example, where they're trying to move a lot of steam throughout the plant, and then they need to cool it down by injecting water to get it to a point that it can be used for an application. Very low flows we can do as well, a micro flow control valve. And this is one where literally we're talking about a CV of 0.0001. So you can imagine the flow capacity through there, and the plug itself is almost, it's very similar to a needle. So we can do very small flows. Application for this would likely be, for example, applications for this would be if you're doing injection, so chemical injection or any type of additive ingredient injection, that might be where you'd want to use this. Went through that. I know I spent a lot of time on the globe control valve. The reason for that, and I will go through the rest of this relatively quickly, the reason for that is that it's still the most versatile. Now, one of the downfalls of the globe valve is that because of its body style, you can only get so much CV. There's only so much capacity you can get through that. So you think of a 4-inch valve, you can only get so much capacity through that. So what do you do if you want good controllability, but you still want to get a higher CV value? You need to get a higher amount through that valve. Well, you can look at quarter turn valves. And the first one I'm going to talk about is what's called a rotary plug valve. So if you just focus on this picture at the bottom here, you can see it basically looks like somebody took a ball valve and cut it open. And in essence, that's what's been done here. So you can imagine when this is open, and because it's a quarter turn, you only have to turn it 90 degrees to get it fully open. But you can imagine when that's at 90 degrees now, the amount of flow that's going through that. It's almost the entire valve body, or full bore, as they say, worth of flow. So that's one of the advantages of a rotary plug valve. The beauty of the rotary plug valve as well is that the face-to-face dimensions of this valve is actually set up to be the same face-to-face dimensions of a globe valve. So you can take these rotary plugs and put them into globe valve applications should you require a higher CV. The globe valve is going to give you the best controllability and best performance. The second best you're going to get is the rotary plug valve. Okay, still a high degree of controllability. And how we get away with that, or able to do that, I should say that, is because we've got this double offset. And basically what it is the center is offset slightly from the body and slightly from the center line. This allows us to, the moment the plug lifts off the seat, it's no longer in contact with the valve body, and it's no longer in contact with the seat. This gives us a high degree of controllability now. This also eliminates any friction during the operation. There is no friction. With low friction, we're able to get way less wear out of it. Again, we want to reduce the amount of times you need to touch the valve. So reduced wear on the valve. We can actually get away with a much smaller actuator as well, because you have a lot less torque that's required. The other beauty of this design is if you look at the bottom picture, bottom right, you can see that even at fully open, there's still a path for product to get around the valve, or around the plug, I should say, through the valve body. This is good if you have slurry applications. You know, Mitch and I had an application where we dealt with a rendering plant where they were looking at this valve because of their slurries that they have and so forth. So that's another good application in looking at using this. Just to show you quickly, the point of showing you this here is that they have the globe valve face-to-faces, okay? ISO patterns as well. And depending on the application that you need, we can design, or we can advise what type of actuator to put on. Just like the globe valve, there's sometimes cavitation issues, sometimes there's blasting issues, and we need to deal with that, not being able to change the valve body size. This is how that's done. Again, they look relatively familiar or similar to what we talked about. And again, we're just trying to reduce the velocity in order to manipulate the pressure drop going through the valve. We have different types of actuators: spring return, rack and pinion, and piston. The most common and accurate is spring return. Rack and pinion is really one if you're in a, you don't need as much controllability. And then piston is for the higher temperatures and pressures. On the rotary valve front, we also has what's called a segmented ball valve. And a segmented ball valve is just that. We've cut a section of the ball out. Typically, a ball valve is not great for controllability. It's great for on and off. By making this little adjustment here, we're actually giving it a flow control characteristic. So now you can use it for flow control situations, not only just on off. You may have heard it called a V-notch or a V-ball. That's the same idea as this. So different pressure classes, we can go up as high as 12-inch. Specialty materials are available if need be. So you can imagine the CV through this is, again, higher than what you'd see in a globe valve. Now we're going to talk about butterfly valves. When we talk about butterfly valves, at Samson, we talk about high performance control butterfly valves. We do have some butterfly valves for on-off, but the majority of what we deal with are high control and high performance butterfly valves. Typically a butterfly valve, you can imagine, one of the biggest advantages is very high CV. Because if you have a 4-inch, you're almost getting a full bore 4-inch through that valve. Some of the issues with butterfly valves in the past have been the controllability. It doesn't give you great control. And a lot of that has been the friction between the seat, the disc to the seat and how it operates. So there's what's called a triple offset design. And I'm not going to get into too much of the specifics, except to understand that there's an offset from this point. It's the first offset. The second offset is just offset from the seat. And the third is it's just offset from the center a little bit. What this is meant to do is eliminate those frictions. So it eliminates the friction on opening. It eliminates the friction on closing. It actually gives you better controllability when the valve is open. There's usually more hysteresis when it hits the seat. When you don't have a triple offset, with a triple offset, you've now reduced, if not eliminated, that hysteresis. So that's one of the great advantages of a triple offset butterfly. The other nice advantage of our butterfly is that traditionally, if you're going to have to replace anything on a butterfly valve, it's going to be the seat. The seat is your wear point. With a lot of designs, what happens is you have to bring the entire valve assembly into a shop and you have to tear it apart, including removing the disc, just to get at the seat. This is a lot of work. It's very laborious and so forth. Our design, if you can notice these three pictures here. So the three colors, I should say, we have green, we have blue, and then if you can just see, the yellow is actually the seat. So just by removing these two retaining rings, one on the seat, or one on the disc, excuse me, one on the valve body, you're actually able to get at the seat and replace it without removing the disc. This gives you the opportunity to do this in the field, or not necessarily in the field, but in your shop. It doesn't have to be taken and shipped out somewhere or sent out anywhere. It can be done in our shop. It can be done in your shop. So different sizes, 3-inch to 120-inch, 150 to 2,500 pound pressure classes, different materials of constructions. Again, the real advantage of a butterfly valve is, if you can imagine a 12-inch globe valve, as much as it's the globe valve is going to give you great controllability, but at 12-inch, it's a very, very large valve. A butterfly valve has probably got a face-to-face of at 12-inch, probably 12-inch or less. So this is why you see a lot of butterfly valves in water, wastewater applications, because their piping is so big. 24-inch, I've seen a 60-inch butterfly valve as well. So those are a lot of applications. Again, traditionally, it's been used for controllability, on-off, not controllability. Now with triple and double offsets, you can get a controllability. Different types of connections, wafer lugs, double flange, butt weld, depending on what type of connection you're looking at and what the application calls for. Like we mentioned before, with all the valves, you can have cavitation and noise issues. In this case, we just take those velocity diversions or diversion plates, and we have them actually mounted on the disc itself. Does the same thing, reduces the velocity, manipulates the pressure drop so that we don't have any cavitation or flashing issues. Sometimes you have a butterfly valve that has to be mounted in a location where you can't get to it. So in this case, we have this top entry design where you can get at the butterfly valve just by coming in the top, again, to replace the seat. So that is something that's available as well. Should you have an application where, let's say, the pipe is buried, as long as you can have access to this, you wouldn't have to take out the entire assembly. You could replace the seat just by getting in from this top entry access. Other types of butterfly valves that we have, again, now we have a double eccentric, still, or double offset, just 2 offsets instead of 3, still good for controllability, okay? A lot of applications for these, again, you're looking at on-off, or ones where you want a very high CV rate, where you can live with the reduced controllability versus CV. We can also do these in Teflon coated. So Teflon coating would be if you have high abrasion, high corrosion. Chemicals, for example, might be an application where you'd want to look at this. One of the nice advantages is compared to our design compared to other designs is that we have the thickest Teflon liner in the market, which means you're going to get a longer life out of it because we're talking about chemical abrasion and physical erosion to that liner. And if it's a little thicker, obviously it's going to last a lot longer. Most designs are about 3 millimeters and ours are between 8 and 10 millimeters. We can also do a Teflon coated globe valve. Not very common, but we have seen it as well. Some of the applications where you'd want to look at Teflon coating just in general, bromine, chlorine acid, sulfuric acid, mixed acids, acids, different types of chlorides, mining applications as well. Sometimes you get high abrasion. When you get into really high abrasion applications, though, something to consider would be something a little bit more than a Teflon, and I'll talk about that in a moment. We can also do a PTFE or PFA lined ball valve for those types of applications. When you get into, and I'm going to use mining as a good example, you have tailings, for example, or rock particles that are going through. Even on a Teflon line, eventually that's going to erode the liner. Should you want an application where you want to put a valve in and want to get a very long life out of it, something to consider is a ceramic lined valve, ceramic lined ball valve or ceramic disc valve. The advantage of the ceramic is obviously the hardness. I always like to use the analogy, if you think of a metal plate and you take your fork to a metal plate, you know what's going to happen to it. It's going to start to eat away at it. If you take your fork to a ceramic plate and do the same thing, it's going to last a lot longer, and it's going to be a lot harder. So very hard applications is where you would use it. A lot less maintenance as well. Just going to go back. One of the nice things about this design is that it's a three-piece design, which means you can take the valve out of service, you can take it apart and replace individuals. You can replace the ball, you can replace the liner on the inlet and outlet, you can replace the packing and all that. You don't have to send it away to the factory to be done. It's very simple to replace pieces on this. A good example would be, we had a customer that on the outlet had found a wear point on the ceramic where it was starting to wear down. But on the inlet, they didn't see a wear point at all. So all they did was actually took apart the valve. These two pieces were identical in size. They just moved the outlet ceramic liner to where the inlet ceramic liner was, and now they just got double the life out of their valve because they know how long that one point's going to wear. You see, we have different ball styles depending on the type of controllability that you're looking for that we can do as well. So again, it's not meant to be on-off. This little V-shaped triangle, if you will, is to give you a good controllability and throttling through the valve. Different sizes, 1 to 12 inch, different pressure ratings, high temperature ratings are available as well. But again, high chemical or very, very corrosive chemical or very abrasive applications, high erosion, that's where you'd want to consider using these types of ceramic valves. We have the same thing, but a sliding disc. It's not unlike a gate valve, the sliding disc. We can only go up to 3 inch though. But again, same type of application. Also, we have ceramic lined hoses and piping. So the hose at the top here is actually a flexible hose, and it has small pieces of ceramic inside each one of those ribbed pieces. So that would be a flexible hose. A lot of what we see is an elbow, and the reason for that, if you can imagine that there's flow coming through and it's highly abrasive, the moment it comes into an elbow, it starts causing eddies, and that's going to increase the amount of erosion that's happening. That's why we see ceramic elbows in a lot of applications as well. We can also get conductivity. You can notice here, it has these two wires. That's actually a conductivity sensor. So what that actually does is tells you how much the pipe has eroded, because it changes the conductivity reading. So as this erodes, that conductivity reading will change, and then it can actually tell you that, hey, you need to change this. We talked about the different applications: mining, bioethanol, fertilizer, salt is a good one, plastics and polymers, lime slurry. We've had a lot of experience with lime slurry using ceramic valves as well. Okay. Lastly, on the valves, I want to talk about the forged ball valves. We have a line of ball valves, floating and trunnion design, that are specifically designed for heavy industry, heavy chemical and oil and gas industries. So higher temperatures, higher pressures, you can see it's a very beefed up body, very large actuator as well. So we do have the capability of doing those as well. Positioners and accessories. So far, everything we've talked about has been a valve. A valve is a relatively dumb device. It is a dumb device because it only does what we tell it to do. If we put air to it, it's going to open or close. How much it opens and closes depends on how much air we put into it, or an electrical signal, vice versa. What's required is something to be a little bit more accurate for the valve. In this case, what it is it's called a positioner. The positioner mounts on the valve, and what the positioner does is it not only gives you feedback, but it actually controls things. A good example would be if you're trying to control a valve at 50% open, for example, and you send 50% air to the valve, and you're just assuming it's 50% open, but you really don't know. It might only be 48% open. Well, why is that? Well, maybe there's a break in the airline somewhere, so you're not getting a full 50% of the air to the actuator. Maybe there's a plug and seat issue because of erosion. Could be 10 or 12 different things. By having a positioner on there, all it knows is, oh, you want 50%. It now decides for you how much air is required to open the valve or close, open or close the valve 50%. It can also give you feedback as well. So different types of positioners for different applications. We have them with protocols. Again, nowadays we want controllability, we want information. So we have 4 to 20 hearts available, 4 to 20 Profibus PA Foundation Field Bus. We're actually working on, and hopefully we'll have it by next year, an Ethernet IP, power over Ethernet version, where you would literally plug a Cat6 into the positioner. One thing to mention, you notice this adjustment knob here. So this allows you to do the programming, very simple programming on the valve or in the positioner. There's only a few pieces or a few bits of information that are required to actually program a valve. One of the things to be conscious of is that when you change something on a valve, let's say you change the packing, if being familiar with instrumentation, if you change something on a piece of instrumentation, you usually have to do some type of recalibration or verification. A valve is no different. If you change the plug, if you change the seat, you change the packing, for example, you need to do some type of verification or calibration. In the mechanical world, it's called stroking the valve. In a lot of cases, after you've done this adjustment, you'd have to stroke the valve manually on a bench test, where you'd have to set up 25%, 25%, 50%, 75%, ramp it up, ramp it down multiple times, and so forth. One of the beauties of the 3730 positioner is this little button here actually is what's called an auto tune function, where it goes ahead and strokes the valve for you. You don't have to do anything else, as long as you haven't changed any of the parameters. So let's say you changed the seat and plug because they needed maintenance, or let's say you changed the packing. You hit the auto tune function, you can then go off, have a coffee, come back, and that valve is quote unquote calibrated and ready to go. I talked about some of the feedback you can have. So you can have position feedback, binary feedback, binary switches, leakage sensor, for example. If there's any air leakage, it will tell you that. If there's an external sensor that's needed to be plugged into the valve, it can have that. Solenoids, if you want alarms or switching to be happening as well. Here you see the word Trovis View. Trovis View is actually the software that comes with these positioners that gives you advanced diagnostics. So some of the things you're going to get for Trovis View would be complete valve history, local errors, travel, and deviation. So I mentioned earlier that let's say we have a plug and seat issue. That could be picked up by the travel deviation only because, well, now it's traveling a little bit more to hit 50%. So why is it traveling a little bit more? Cycle counter. If a valve is supposed to be good for 1 million cycles and I'm only at 500,000 and I'm getting problems, what's going on? Or if I'm getting close to 1 million, I know that, okay, it's probably due for maintenance. Hysteresis, end position, deadband test, all this information is available through the Trovis View program. And it's very easy to just plug in or have that program work in conjunction with your own local historian. Another beauty of our positioners is they can be mounted on not only different styles of valves, but other people's valves as well. So we have mounting brackets to mount on pretty much any valve configuration that you can think of. So should you decide or have a valve that you go, geez, I'd really like to get a Profibus or a a foundation field bus or a heart, but I don't want to change the valve, there's nothing wrong with the valve, then all you need to do is put one of our 3730 positioners on there. Another thing that I want to point out is this picture here is that we can have a remote setup as well. So if the valve is up high, but you want the positioner down at an eye level, we can have a remote setup on the positioner as well. So I've gone through a lot of different things. At the end of the day, what's important is sizing the valve. Sizing the valve is the most important because you want to make sure you have the right valve for the right application. So we want to know things like inlet pressure, outlet pressure, what's the media, what's the temperature, is it on off, things of that nature, so that we can properly ascertain, are you going to have cavitation issues? Are you going to have flashing issues? Again, we could have a situation where a customer has a 2-inch pipe, but it's sized out where it needs to be a 3-inch. Now we need to have a conversation going, okay, is there any chance of doing something different with the piping? Or we're going to have to put different types of cavitation and flashing trim in there so that we don't have any of these issues. To summarize, Samson takes a lot of pride in our manufacturing. We actually control over 90% of every part that's manufactured because we do it ourselves. So even as far as everything on a control valve, even the nuts, we do all those ourselves. So we have a very tight quality control on all of the products that we manufacture. We want to make sure that if a customer or yourself purchases a Samson product, that it's in for a very long time. My friends at Gerrie Electric and I ran into an application where we found this 4-inch steam valve at a customer's that had been there for 20 years, and it was still relatively working. It was sticking a little bit when the plug opened and closed, but they were still getting the controllability they needed out of it, and that was over 20 years. So that's definitely what we need, what we aim for. The total cost of ownership, making sure that you have a product that's going to last a very, very long time. That's all I had. Thank you very much. I will pass it back to Mitch and open up for any questions.